Hi, my name is Rogerio Caravalho. I'm training and support manager here at Dolphitech, and today we're going to use the dolphicam2 to inspect a slice of a sailboat mast made of CFRP material. Today we're going to be using a 2.5 megahertz BF transducer with 8mm delay line attached to it. The thickness of the part varies from about 4.8 millimeters to something around 8 on the thicker parts, and let's see what we can find. There might be some damage to this part. And we're going to set up using this part over here. So find a place that has a good back wall. A little bit of gel. TRM, turn it on, and put it on the back. See that there's a back wall there, but it's really slight, so it can go to gain, enable TCG, and a little bit more of that back wall. Transmitting elements, 16. Signal averaging, go to 4. Transducer pitch, I can leave at 1/4 millimeter, but just so you know, this is the kind of effect that we have when we put it on, that I'm leaving at 1/4 millimeter. We go to coverage. My delay is pretty good. My range is too big at 15.8, so I'm going to make it smaller. About what I need. Velocity, I can select CFRP, just close enough. And you can see that I already have a pretty good response. Signal and image. Change my color palette. For my amplitude, I like to use jet. Makes it more clear. And time of flight, I just leave it as is. Image filter, a Gauss filter, and my digital filter 3. You can see that that's enough, and I scaled it to 1.5, my scaling factor for the filter. Now I go back to my image, time of flight, set up my gate, compress the palette a little bit so you have 2 different colors of thickness. And I guess we can go for a scan. I'm going to get the part that we already set up. You notice that there's a curvature to it, so that's going to be reflected on our C-scan. So you're going to see as I put it on, there's some areas that change because of lack of coupling, because of the curvature. But our main image here in the middle, you can see we have a really good signal from the back wall. And right here, this is what we could call a good part, good area of the part, because you can clearly see the front and the back wall. There's nothing in between. So as we move along, you start seeing, especially on the B scan, a difference in thickness of the part, on the part. That can be also shown on the C scan by the change of color of our time of flight. And now keep going all the way back here. thickness change. Bring back to the fin. And over here what you're seeing is some kind of indication that can be seen by both the C scan and also on the B scan. Is pretty clear. And you can see that's an indication because it's repeatable. It can get off of it and come back on, and it's there. You can see that this impact area right here, this part has been impacted here in the lab, and you can see, because it's close to the curvature, I'm getting some edge effect as well on the probe, but it's clear. Once you get off, you can just get back on it, and you have different thicknesses of the impact damage that you can see in both the B scan and the C scan right here. So freeze it. You can see right there a big area, and we can measure it at about 1.38 millimeters from the surface of the part. So maybe 2 plies down. So you can see a back wall around 5 millimeters. First part of the impact damage, which is the yellow part, at 4.1, and then the thinner part at 1.38 of our impact damage. Okay, over here in the B scan, you can also see a thickness change. There's a thickness change right there. Your front wall about 5 millimeters. 5.2 millimeters, 5.54 millimeters. So there we have it, guys. We just quickly inspected this slice of a sailboat mast in composite. As you can see, there is some damage on it that has been found fairly quick. So we think that that's a fairly good application, especially for the boating industry, when you have different kinds of applications that you can look into on different parts of the boat. Okay, thanks for watching.